Hey everyone, so today we're going to start our quadratics unit. So we're going to just start off with some features of a parabola. And if you remember what a parabola is, it's like the U-shaped graph. So it could be up or down. So we're going to talk about these. So our objective for today is that you will be able to identify features of a parabola and find the vertex of a quadratic equation when it's in standard form. So going through this video, we're going to talk about features of a parabola and then talk about how to find the vertex, the axis of symmetry, and the y-intercepts. So first, the features of a parabola that we're going to be looking at are the vertex, axis of symmetry, max and min, and today we're just going to look at the y-intercept. So a vertex is the turning point of the parabola. So of the ones I just drew on the title page, the vertex is like where it goes from decreasing to increasing or increasing to decreasing. So it's like really the turning point. So your vertex is your max or min point. When it's at the bottom like this one, it's your minimum because it's your lowest point of the parabola. When it's up top here, it's your maximum because it's your highest point of the parabola. Your axis of symmetry goes right through the vertex, and it means that like this point over here is the same distance away from this point over here because your parabolas are symmetric every single time. And then of course your x-intercept would be where your parabola crosses the x-axis and your y-intercept is where it crosses the y-axis. So looking at these parabolas, the one on the left, this point right down here would be your vertex because it's your lowest point of the graph. So you're always looking for your lowest or highest point. And since we found that to be the vertex, we're going to draw a line right through it to be our axis of symmetry. So this axis of symmetry means like if we pick this point right here, we count 1, 2, 3 spaces to our axis of symmetry. So then on the other side, we can count 1, 2, 3 spaces to get the same point over here. Then our x-intercept would be right here where it crosses the x-axis. And our y-intercept would be this point right here where it crosses the y-axis. So most importantly today, we're going to focus on vertex and axis of symmetry. So this graph on the left-hand side, it's opening up, but it can also open down just like the one on the right-hand side. So on this right-hand side, this point right here is our highest point. This is our maximum. This would be our vertex, and then right through it is our axis of symmetry. So your vertex. So all the equations we are going to be looking at right now are going to be in standard form. So when a quadratic equation is in standard form, it's always y equals ax squared plus bx plus c. So it could be, for example, y equals 2x squared plus 4x plus c. They could be minus or plus, let's say, erase that, plus 10. So there could be minus signs, or like this could be a 1, but pretty much the number in front of your x squared is your a, the number in front of your x is your b, and the number on the end is your c. So we're going to use that when we're looking at this equation. So to find your x value of your vertex, you're going to do negative b over 2a. So you take the opposite sign of this number in front of the x, so we'll get negative 4 in this case, and then 2 times the number in front of your x, so 2 times 2. So you get negative 4 over 4, which is negative 1. So that means your vertex is at negative 1 comma something. Then to find the y value of the vertex, we have 2 different options, so we're going to go through both of them. So option 1 is that you can plug in your x value that you just found, which is negative 1, into the original equation. So let me pull up a different color. Let's do red. So you would do y equals negative 2 times negative 1 squared plus 4 times negative 1 plus 10. Then you solve it using your order of operations. So you do negative 1 squared first. So it's 2 times 1. Negative 1 times 4 is negative 4 plus 10. We get 2 minus 4 plus 10. So our y value is 8. Now you could do option 2. You take your same x value and you look at your bx. So your bx from right here, so in this case it's 4x. So you do 4 times your negative 1. You always have to half it, so like divide by 2, and then add on your ending number. So in this case, we get negative 4 divided by 2 is negative 2 plus 10 gives us our 8. So you get the same answer either way, so it's really up to you. And I'll show you 2 examples of doing it each way. So for these first 2, I will use option 1. So to find the vertex, in this case, y equals x squared minus 2x plus minus 5. Our a is just 1, because when there's no number in front of your x, it's just 1. B is negative 2, because you can't ignore the negative signs. And C is negative 5. So I'm going to use those to plug in to find our vertex. So x equals negative b over 2a. So you take your opposite sign of b, so b is negative 2, so we make it positive 2 over 2, and a is 1. So in this case, x just equals 2 divided by 2, which is 1. Now to find the y value of your vertex, I'm going to plug this in back to this original equation. So y equals 1 squared minus 2 times 1 minus 5. So we get 1 minus 2 minus 5. So we get that y equals negative 6. So your vertex becomes 1, negative 6. Now we're going to look at our next point, or our next equation. So we have y equals negative 2x squared minus 12x plus 7. So in this case, our a is negative 2, because again, you can't ignore the signs. B is negative 12, and C equals 7. So for these, you don't really need C to plug in for anything, but we're going to point it out anyway. So now we're going to do our x equals negative b over 2a. So negative b, we want the opposite sign of b, so positive 12 divided by 2 times our a is negative 2. So we get 12 divided by negative 4, which is negative 3. So our x value is negative 3. And now we're going to plug this into our original equation. So we get y equals negative 2 times negative 3 squared minus 12 times negative 3 plus 7. So when we solve it, negative 2 times 9 plus 36 plus 7. So we get positive 18 plus 7, so it's 25, which means that our vertex for this problem is negative 3, 25. Now I'm going to show you the example using option 2. So for y equals negative x squared plus 16x minus 10, our a equals negative 1, b equals 16, and c equals negative 10. So we use our x equals negative b over 2a still for our x coordinate of our vertex. So negative b becomes negative 16 over 2 times negative 1. Positive 16 or negative 16 divided by negative 2 becomes positive 8. So now we're going to do our bx, but plug in the x. So we have 16 times 8, always half it, so divide by 2, and minus 10. So 16 times 8 divided by 2 gives us 64, minus 10 gives us 54. So our vertex is 8, 54. Over here, A equals 2, B equals 28, and C equals negative 32. I'll change the color of the pen. So to do our x equals negative b over 2a, we get negative 28 divided by 2 times 2. So negative 28 divided by 4 is negative 7. And now we're going to use this x equals negative 7 to do the same thing we did on the left side. So we take our 28x, but plug in negative 7. Always divide it by 2, and then add on your plus c. So this becomes 14 times 7, negative 98 minus 32, which is negative 130. So our vertex is negative 7, comma, negative 130. So these are like huge numbers, but you wouldn't have to actually graph with these big of numbers. So now finding the axis of symmetry. So it's the same exact thing that we've been doing, except now we just need the x value. So when we do our negative b over 2a, that's our axis of symmetry because it always goes through the vertex. So in this case, our a is negative 1, b is 18. So we do negative 18 divided by 2 times a. So we get positive 9. So this is where 9 is on the x-axis. So this isn't necessarily our y value, but our axis of symmetry will go straight through this line. And so your vertex will be somewhere on that line. You could find it by, again, doing option 1 or 2. But right there is our axis of symmetry. It goes straight vertically through our vertex. Lastly, to find your y-intercept, you set x equal to 0 and solve for y. So whenever you do this, anything that has an x term is going to just go away. So y equals negative 10. And then your answer is 0, negative 10. So again, just looking at this next one of y equals 2x squared plus 28x minus 32, anything with an x would just go away and we get y equals negative 32. So we get 0, negative 32. So finding the y-intercept is super easy. It's the x-intercept that's a little harder, but we're going to go into that when we go on to factoring. So today we really just want to focus on finding your y-intercept, your vertex, and your axis of symmetry. Next video, we will talk about actually graphing these parabolas. So come to class with any questions you have, and we will practice.